In this section, we will explore the HUD and UI widgets in the Lyra framework. Lyra UI framework uses the gameplay tags extensively. W underscore overall UI layout is the base UI widget which holds all other UI widgets used throughout the game, including the main HUD. It includes 4 stacks to hold the different UI layers hosted on top of the W underscore overall UI layout. Game layer stack, game menu stack, and modal stack. The UI widgets placed in these stacks are identified using the following gameplay tags: UI layer game menu, UI layer menu, UI layer modal. UI layer game is the tag to identify the main game HUD. W underscore shooter HUD layout is the main HUD for the shooter elimination experience, which is derived from Lyra HUD layout. The different widgets seen over the HUD during the gameplay are placed dynamically using the placeholders called extension points. Each extension point is identified using the gameplay tags. These tags starts with HUD.slot. Some good examples are HUD.slot.teamScore to display the team score. HUD.slot.reticle displays the different reticles for guns. HUD.slot.equipment to display the quick bar slots. And HUD.slot.extra equipment to display the grenade status. Few other widgets like the health widget are directly placed in the HUD. We will understand how these widgets are dynamically added to the HUD in the elimination experience in another lecture. UI layer menu is the tag to identify the different on-top menus in Lyra. Lyra front-end menu, host session screen, experience selection screen, Lyra game menu are some of the examples for the UI layer menu. UI layer game menu is the tag to identify the menus which appear when a button is pressed. Show leaderboard menu is a good example. UI layer modal is the tag to identify the modal screens on top of the game screen. Lyra settings screen is a good example for this. The settings screen is opened from the Lyra front-end menu or the Lyra escape game menu. Thank you for watching this lecture. See you in the next one. In this lecture, we will explore the weapon system in Lyra. Lyra has 3 inbuilt weapons: pistol, rifle, and shotgun. Let us see how these weapons are configured in Lyra. Lyra ranged weapon instance is the C++ class provided to configure a ranged weapon like a pistol, rifle, shotgun, or any other custom ranged weapon. Lyra provides a base weapon instance derived from Lyra ranged weapon instance with default values for the weapon configuration. Go to the plugins, shooter core content, weapons, weapon instance base. Some important settings are number of bullets per cartridge, which means how many bullets will be fired during a weapon fire. A good example will be pistol fires a single bullet while a shotgun fires multiple bullets at the same time. Damage range, which deals with the maximum distance the weapon can cause the damage. There are 3 animation montages which can be configured for the character holding the weapon. Weapon equip montage when the character picks the weapon, weapon unequip montage when the weapon is replaced, and the melee attack montage when the character can do a melee attack using the gun. Equipped anim set is the animation layer for the specific weapon. Unequipped anim set is usually the unarmed animation layer. More than one animation layers are provided for equipped and unequipped anim sets, and the specific animation layer is selected based on the tag provided. For example, cosmetic animation style masculine tag selects the masculine animations and the feminine tag selects the feminine animations. There are also other settings which are self-explanatory by hovering on the properties. Right-click the base weapon instance and select Reference Viewer. You can see the child blueprints for this. Lyra provides presets for the weapon instance for weapon instance pistol, rifle, and shotgun. The next is the Lyra equipment definition. There are three presets available for the Lyra equipment definition for the pistol, rifle, and shotgun. Open the shooter core, weapons, pistol, WID_pistol file. The weapon instance for pistol is configured. The ability sets for shooter pistol is configured. We have already seen the concepts about the weapon ability set in an earlier section. Open the ability set for pistol. Abilities weapon fire, weapon reload, and weapon auto reload are configured here. The input tags for weapon fire and weapon reload are also configured, which connects the respective input actions for weapon fire and weapon reload. For example, mouse left click fires the weapon and clicking R reloads the weapon. Next, in the actors to spawn section, the pistol blueprint is attached to the weapon right hand socket weapon_R. The location, rotation, and scale of the weapon are configured here. Next is the Lyra inventory item definition for the weapon. The Lyra equipment definition WID_pistol is configured here. The quick bar icon for the weapon, the magazine size, magazine ammo, and the spare ammo quantity, the skeletal mesh for the pistol, the widgets for the reticle for the weapon, and the ammo counter, which gets displayed on the HUD on screen, are configured here. These weapons can be equipped by the playable character using the weapon spawners. We will explore weapon spawners in the next section. Thank you for watching this lecture. See you in the next one. In this section, we will explore the UI screen flow configuration for loading an experience in Lyra. Go to the Content, System Frontend, Maps folder. Open the Lyra Frontend level map. The UI screen flow starts from the Lyra loading screen, followed by the front-end screen. Clicking on the Play Lyra button loads the main menu screen. There are three options available in the main menu: Quick Play, Start a Game, and the Browse option. Lyra is built for both single-player and multiplayer game development. We will configure multiplayer options later in this course. Until then, it works in the single-player mode with player and AI boards. Clicking on Quick Play loads a random experience straight away and loads the level map. Clicking on the Start a Game loads the Host the Game screen. All the experiences configured to show in the front end are displayed here. Clicking on an experience loads the level map for that experience. Click on the elimination experience, it loads the experience level map and the game starts. Now let us see how this entire UI screen flow is configured. Everything you see in this UI screen flow can be configured with your own images and text for the widgets. The front end screen is also an experience. You can see an environment in the background with a camera moving in front. The menu is displayed on top of the environment background. Lyra front-end experience is the Lyra experience definition loaded here. Go to the Content System Front-end folder. Open the Lyra front-end experience. This is a Lyra experience definition similar to the elimination experience definition we saw earlier. We will skip a few areas in this for now and focus on the most important sections. There will be no pawn data configured for the front-end experience. Under Add Components, Lyra front-end state component and Music Manager component are configured and loaded to the Lyra game state. Lyra front-end state component is used to configure the Lyra startup widget and Lyra front-end widget. When the front-end is loaded when the game starts, the Lyra front-end widget is loaded. But in case of advanced system like console, an additional widget called Lyra startup widget loads with a start button in it. Clicking on the start button loads the Lyra front-end widget. This is automatically handled by the system. For Windows platform, which we are dealing in this course, Lyra front-end widget is loaded directly, so Lyra startup widget can be ignored for now. Music Manager component is used for the background procedural music. This is a separate topic. We will explore it in a later section. Until now, we discussed about the Lyra experience definition, which defines a Lyra experience, which can be a game logic like elimination or control points, or a user interface menu screen. Next, we will explore the Lyra user-facing experience definition, which defines how an experience is loaded on screen. For example, when we start the game, the Lyra loading screen loads first, followed by the front-end menu screen. This flow is defined in the Lyra user-facing experience definition. This flow definition data asset is applicable for both the front-end screen and also for other experiences like elimination or control points. Let us first look at the DA frontend, which is the default Lyra user-facing experience definition for the Lyra frontend experience. Go to the Content System playlist. Open the DA frontend data asset. The map ID represents the level map for this Lyra user-facing experience definition. Lyra frontend map is configured here. Remember the background environment with a moving camera and the front-end menu. It's the Lyra front-end map. Experience ID is the corresponding experience data asset, Lyra front-end experience, which we saw in detail a while ago. The tile title, description, and the tile icon are used to show the experience tiles in the start game screen seen earlier. This is mainly applicable for the elimination, control points, or any new experience you create later. For the front-end experience, ignore this for now. I will show you where it is applied in a later section. Show in front-end checkbox is important to make it visible in the start game screen. The loading screen widget is the screen which is shown when the experience is loaded in the background. Due to the multi-threaded and modular design of Lyra, the experience will be loaded once all the modules are loaded and the experience is ready. Once the front-end screen is loaded, click on Play Lyra and start a game. The experiences are loaded on their tiles configured in the Lyra user-facing experience definition. Now clicking on an experience loads the experience map. Let us take the second example of elimination experience. We will open the Lyra user-facing experience definition for this. The maps and Lyra user-facing experience data set for the elimination experience are located in the Shooter Maps plugin. Go to the Shooter Maps Content System Playlists folder. Open the DA Expense TDM data set, which is the Lyra user-facing experience for elimination experience. You can see the elimination map L expands configured for map ID. Experience definition for elimination is configured for the experience ID. Title description and tile icon are configured. Show in front-end checkbox is selected to display the experience tile in the start the game screen. And the loading screen widget is also configured here. Thank you for watching this lecture. See you in the next one. In this lecture, we will explore the Lyra pawn data which is configured in a Lyra experience. In the last section, we saw the field default pawn data in the elimination experience. Hero data underscore shooter game is Lyra pawn data configured to the default pawn data. Open the hero data underscore shooter game data asset. It has a pawn class, a set of abilities, an input config, and a camera mode for the pawn. The pawn class is assigned to the hero shooter mannequin. Hero shooter mannequin is the pawn of type character in Lyra with a lot of features inbuilt. The characters spawned during the gameplay are copies of this pawn class. We will explore the hero shooter mannequin in detail in a separate section. Pawn or the character has a set of abilities. We already learned the different gameplay abilities for the character in an earlier section. These abilities for the pawn are grouped under a dataset called ability sets. Open the ability set underscore shooter hero. The abilities for the character are added under the granted gameplay abilities section. Input tags are associated to the gameplay abilities which are triggered by an input action. Hero jump, hero death, hero dash, emote, quick bar slots, ADS, grenade, drop weapon, melee, spawn effect are the abilities added. Under gameplay effect section, the gameplay effect for the player GE underscore is player is added. This gameplay effect adds a granted gameplay tag lyra.player which is handled in C++. In the input config section, the input data underscore hero dataset is added. It is of type Lyra input config. All the player specific input actions are configured here. Third person camera mode is configured here for the player. Thank you for watching this lecture. See you in the next one. A Lyra experience is a configurable data asset which loads a set of components, input actions, widgets, and the playable game character. It's about how we assemble the modular components built for the experience like a Lego building. We will look into the elimination experience and how it is assembled for the gameplay. This experience will be later loaded into the map or the level. Open the plugins, Shooter Core Content, Experiences folder. Open Shooter Game Elimination. The modules needed for the experience gameplay logic are assembled together in a Lyra experience definition. A Lyra experience definition is a configurable data asset. We will explore the Lyra experience definition for the elimination experience in the Shooter Core Game Feature plugin. Under the Game Features to Enable section, add the game feature plugins used in the experience. In this case, choose Shooter Core. Default pawn data is the data asset defining the pawn, which can be a simple pawn or a character. We will understand this data asset in detail in the next section. Action sets are grouped set of actions. In the elimination experience, there are 4 action sets. Shooter game shared input is the action set dealing with the input configuration. There are 2 types of actions loaded here: input binds and input config. Action add input binds associates an input tag for each input action. First, we will explore the input bind called input data shooter game add-ons. Some of the common input actions like show scoreboard, ADS, grenade, emote, melee are configured along with the input tags. These input tags are labels for the input actions which are used to represent the input actions throughout the gameplay ability system. Next comes the add input config action. All the PMI or the player mappable input configs are added here. Under feature dependencies, shooter core is added. The next action set is shooter game standard components. Under the add components action, 4 components are added. The Niagara number pop component displays damage pop-ups over the head of the characters in the game. It is attached to the Lyra player controller and available only at the client side. The player controller displays the damage pop-ups on the target characters using the Niagara number pop component, and this is not viewed by other network players. It will be visible only for the client or the local player. The quick bar component is used to manage the equip and unequip weapons to the quick bar slots on-screen inventory widget displayed in the HUD. It is attached to the player controller and available for both the client and the server. The nameplate manager component displays a head-over nameplate only for the remotely joined player characters. It is attached to the Lyra player controller and waits for the register nameplate messages from the player characters. It is available only at the client side. The nameplate source component is attached to the player character or the mannequin. It sends the nameplate registration to the nameplate manager component via gameplay messages. Its main purpose is to add or remove the nameplates for the mannequin. This is also a client-only component. The next action set is the shooter game standard HUD. Before we explore this action set, let's see how the HUD and the widgets works in Lyra. The main HUD or the heads-up display is the screen overlay to display all the widgets during the gameplay. The UI elements displayed on top of the gameplay are layered using the gameplay tags in Lyra. There are 4 gameplay tags for the UI layers: UI layer game, UI layer game menu, UI layer menu, and the UI layer modal. We will go through this during the course of this project. For now, we will focus on the HUD and the widgets displayed on the HUD. The main HUD is tagged to UI layer game. There are 11 widgets added to this HUD. We will focus on the following widgets in this section: elimination feed, quick bar, top accolades, weapon reticle slot. There are a lot of mobile specific widgets and diagnostic widgets. We will ignore them for now as they won't be displayed during the normal gameplay. Let us open the shooter HUD layout widget, which is a parent widget hosting all other widgets over it. The positioning of the widgets in the HUD is done using the OpenUI extension point widget. They are just placeholders with tags. For example, let us consider the quick bar widget. You can see the extension point equipment, which is placed in the bottom right corner where you see the quick bar slots during the gameplay. It also has the tag HUD.slot.equipment associated to it. Same applies to the other widgets like elimination feed, top accolades, and weapon reticle slot. These widgets are dynamically added to the gameplay using the modular features of the game feature plugin. There are also other widgets like ability progress bar, health bar, which are directly placed in the HUD. The next action set we will explore is the basic shooter accolades. We already saw the accolade registry in the last section where we configure the data needed for the accolades. In the basic shooter accolades action set, the rules needed for the accolades to display are configured in Elim chain processor and Elim streak processor. Open the Elim chain processor. Here, the chain time limit value is set. The default value is set to 4.5. And there are 3 rules set here. If you kill 2 or 3 or 4 players within 4.5 seconds, you get the accolades double, triple, and quadruple. Open the Elim's tree processor. Here 4 rules are configured. 5, 10, 15 or 20 kills will get the accolades Spree, Rampage, Dominance and Unstoppable. Under the Actions section of the experience, 4 actions are configured. Common ability sets specific for the elimination experience are grouped under Ability Set Elimination. Show Leaderboard ability displays a pop-up with the scoreboard when Tab button is pressed, which is configured for the input action Show Scoreboard. Auto Respawn ability gives the character the ability to come back to life again after the death until the timer is active. Next, there are 6 core components specific to elimination experience. Each of these modular components are responsible for specific functionalities in the elimination experience gameplay. Team Deathmatch scoring component attached to the Lyra game state is responsible for the team scores, deciding the winners and losers and end the game. It exists in both the client and the server. Music Manager component attached to the Lyra game state is responsible for handling the music and sound system for the game. It exists in the client side. Shooterbot Spawner component attached to the Lyra game state is responsible for spawning the AI-controlled bots. It's a server-side component. Team Setup 2 Teams component attached to the Lyra game state is responsible for assigning characters in the game to the 2 teams. It's a server-side component. Team Spawning Rules component attached to the Lyra game state is responsible for spawning the characters in the game in the Lyra player start locations. It's a server-side component. Pick Random Character component attached to the controller chooses different character meshes or skins to the characters spawned in the game. It's a server-side component. We will deep dive into these components and understand them in detail in the Lyra deep dive section. These components can be used ready-made when you design a game based on elimination experience or something similar. These components can be considered as a base and extended by adding more functionalities to it. Next, in the Add Widgets action, Score Widget Elimination is added. This widget is again displayed in the main HUD shooter HUD layout. The extension point Team Score is used to host the Score Widget Elimination with the tag HUD slot Team Score. Thank you for watching this lecture. See you in the next one. Lyra framework uses modular gameplay development. In modular gameplay development, anything which can work independently can be developed as a separate module. And each of these modules can communicate with other modules via sending and receiving messages. This approach is very flexible and easy to manage in the long run. Visualize this approach as a Lego building built using multiple Lego blocks. On top of this modular approach to gameplay development, Lyra follows a concept called Game Feature Plugin. A Game Feature Plugin is a group of modular independent modules which can be developed for your game and installed as an add-on. This approach makes it very easy to install and uninstall a game feature without affecting the rest of the game. The advantages of using this approach is that you can develop a base game and then add more features to it later on easily by developing the features as game feature plugins and installing them to the existing game as incremental updates. If you want to use the features of a game feature plugin in another game feature plugin, you can add it as a dependency and use the features. We will look into this in detail with an example. Lyra sample project can be used as a base template to develop any character-based combat games with multiplayer support. The project content folder has some common files which we can use in the plugins we build. The sample project comes with the Shooter Core game feature plugin as an example, with a lot of necessary reusable features for a shooter game development. The project also has a Shooter Maps plugin to demonstrate the features in the Shooter Core plugin. The Shooter Core plugin is added as a dependency to the Shooter Maps plugin. The gameplay logic is called experience in Lyra. There are two experiences provided ready-made in the Lyra sample project: the elimination experience and the control points experience. In the first experience, the elimination mode, where the player and his team needs to kill the enemies in the opponent team. In this time-bound battle, the team with maximum kills win. The players and bots are respawned during the time-bound battle. In the second experience, the control points mode, where the player will try to secure the control points for a period of time to gain points. In this course, we will understand the elimination experience in Lyra. In the Shooter Maps plugin, there are two maps or levels to demonstrate the Shooter Core experiences, elimination and control points. We can create our own levels or maps to use the readily available experiences to get ourselves familiar with the game feature development. Thank you for watching this lecture. See you in the next one. Lyra framework uses modular gameplay development. In modular gameplay development, anything which can work independently can be developed as a separate module. And each of these modules can communicate with other modules via sending and receiving messages. This approach is very flexible and easy to manage in the long run. Visualize this approach as a Lego building built using multiple Lego blocks. On top of this modular approach to gameplay development, Lyra follows a concept called Game Feature Plugin. A Game Feature Plugin is a group of modular independent modules which can be developed for your game and installed as an add-on. This approach makes it very easy to install and uninstall a game feature without affecting the rest of the game. The advantages of using this approach is that you can develop a base game and then add more features to it later on easily by developing the features as game feature plugins and installing them to the existing game as incremental updates. If you want to use the features of a game feature plugin in another game feature plugin, you can add it as a dependency and use the features. We will look into this in detail with an example. Lyra sample project can be used as a base template to develop any character-based combat games with multiplayer support. The project content folder has some common files which we can use in the plugins we build. The sample project comes with the Shooter Core game feature plugin as an example, with a lot of necessary reusable features for a shooter game development. The project also has a Shooter Maps plugin to demonstrate the features in the Shooter Core plugin. The Shooter Core plugin is added as a dependency to the Shooter Maps plugin. The gameplay logic is called experience in Lyra. There are two experiences provided ready-made in the Lyra sample project: the elimination experience and the control points experience. In the first experience, the elimination mode, where the player and his team needs to kill the enemies in the opponent team. In this time-bound battle, the team with maximum kills win. The players and bots are respawned during the time-bound battle. In the second experience, the control points mode, where the player will try to secure the control points for a period of time to gain points. In this course, we will understand the elimination experience in Lyra. In the Shooter Maps plugin, there are two maps or levels to demonstrate the shooter core experiences, elimination and control points. We can create our own levels or maps to use the readily available experiences to get ourselves familiar with the game feature development. Thank you for watching this lecture. See you in the next one. In this section, we will understand the fundamental core elements of Unreal Engine, which builds the foundation for game development. The Unreal Engine is designed to support multiplayer games at the foundation level. So understanding these concepts helps you develop both single-player games and multiplayer games. Actor, pawn, character, game instance, game mode, game state, player controller, HUD and widgets are the fundamental core elements. Any object you can see in the level is an actor. It can be anything like a rock or a simple cube or even the player character itself. If an actor can be controlled by a player, they are called pawn. A character is an advanced version of a pawn with a lot of inbuilt features provided by Unreal Engine. Manny and Quinn are the ready-made characters available in the Lyra project, which can be controlled by the player or AI. Let us understand the fundamental principles of a simple multiplayer game in Unreal Engine. Let us consider a multiplayer game with 3 players playing in 3 different machines in a network. One of them will act as a server and host the game, while the others are clients. Let us see how the different core elements of Unreal Engine fits in this multiplayer game functionality. Game instance. Every client and server has its own unique game instance. The game instance starts when the game is started and exists until the game is shut down. You can use the game instance to handle any data across the levels. For example, match statistics can be received at the client via the game state and then stored in the game instance. This data can be showed during any levels or between the levels or when the game is completed. We can use this for global variables. Game instance is the persistent object which can be used to store gameplay data across the levels. Game mode. Game mode is the overall game controller which defines the rules for the game. The game mode exists only on the server. Most of the built-in events of the game, like the level start, player login, player spawn, which the clients need not know, are handled by the game mode. Game mode defines the player controller, player state, game state, the HUD class, and the pawn or the character class, which will be spawned for the player for that particular level. Each level in a game can have a separate game mode. Game state. The server will have a single instance of game state and a copy of the game state will be replicated to all the clients. This way, whatever data the game mode is processing at the server is sent to the client via the game state. For example, the team scores are sent via the game state and each client can process the data and display the data in their own widgets. Player state. Each player client has its own player state, which is replicated to the server and all other clients. This is extremely useful for each client to know details about the other clients or players. A good example is the hovering nameplate widget on top of the players in a multiplayer game, where the player state holds a variable with the player name, which will be displayed in the widget by each client for all the remotely joined players. Pawn. Pawn or a derived character have a lifestyle. It can spawn, die and respawn. This means attributes like health, which resets when the character dies, can be handled here instead of the player state. Player controller. Each client has one player controller which exists both on the owning client and the server. It is not available in other clients. Main purpose of the player controller is to send the player input to control the pawn or the character. For the pawn, which are bots, there is a separate AI controller. Controller is the parent for both the player controller and the AI controller. HUD and widgets. HUD is specific again to game mode, which is assigned to a level. The on-screen widgets displayed during the gameplay are part of the HUD or the heads-up display. Lyra has its own child classes for the game mode, player state, pawn, and game instance. These classes have useful helper methods to make the gameplay development much easier. Thank you for watching this lecture. See you in the next one. Lyra uses data assets extensively in this modular gameplay approach. Data asset is a visual representation of a class with a set of variables which can be single or arrays. These data assets can be used to store data for these variables and save them as a file. They are used as a plug-and-play module where the data can be changed without compiling the code. They can also be used nested, one data asset within another. We already saw the data asset in action in the enhanced input action section. For example, the input mapping context or the IMC is a data asset. It has a list of input actions configured, which is also a data asset. Input actions can be added or removed from the input mapping context. These data assets are nothing but a visual representation of a C++ class. Thank you for watching this lecture. See you in the next one. In this lecture, we will explore the gameplay ability GA Weapon Fire Pistol along with the gameplay effects, gameplay cues, and the gameplay tags used. We will not go into the complete blueprint implementation in this section, but we will understand how these important features of the gameplay ability system works and how they are configured in the game. Later in the Lyra deep dive section, we will go through the blueprints in detail with an example. Go to the root and search for GA Weapon Fire Pistol. GA Weapon Fire Pistol is the gameplay ability for the weapon pistol. GA Weapon Fire is the parent gameplay ability for ranged weapons like guns. It is derived from the Lyra C++ class, Lyra Gameplay Ability Ranged Weapon. Lyra has provided the gameplay abilities for pistol, rifle, and shotgun. The gameplay ability Weapon Fire has two gameplay cues. The first gameplay cue is gameplay cue Weapon Rifle Impact. This gameplay cue is to produce sound effects based on the bullet impact surface. Go to Edit Project Settings. Under Gameplay Tags, you can see the gameplay cue tag. Gameplay cue.weapon.rifle.impact. Select Search for references. You can see who is using this gameplay cue. It is used by GA Weapon Fire and GCN Weapon Impact. You can now understand how the gameplay tag works. It is mainly used to identify a feature and also to connect two features. In this case, the gameplay ability Weapon Fire uses the gameplay tag gameplay cue.weapon.rifle.impact to identify the gameplay cue GCN Weapon Impact. Let us first understand the gameplay cue GCN Weapon Impact. In the content browser, go to the root and search for GCN Weapon Impact. Open the gameplay cue. Under the GCN effects, burst effects, you can see burst particles for adding Niagara particle effects. Burst sounds for adding sound effect. Burst camera shake for adding camera shake effects. Burst camera lens effect for adding lens effects, decals and more. In this case, different sound effects are configured when the bullet hits different surfaces. Under the burst sound section, spawn condition override, you can select the allowed surface types. For each surface types, separate sounds can be configured. Burst camera shake configures the camera shake for the gameplay queue. This gameplay queue is called from within the gameplay ability weapon fire. Search and open GA weapon fire. We won't get into the details of the blueprint implementation in this section. We will do that in the deep dive section. The gameplay queue is called into the blueprint using the node execute gameplay queue with param on owner. The hit result where the queue needs to be executed is passed as a parameter. The second gameplay queue used in this gameplay ability is gameplay queue weapon rifle fire. This gameplay queue is used for weapon firing effects. It is quite complex and a very good use case for Lyra deep dive. It's not straightforward as the weapon impact we saw just earlier. More than just configurations, there is a blueprint implementation which internally calls sub-blueprints for each effect. This gameplay queue calls the fire function in the B_weapon blueprint. Within the weapon blueprint, there are 3 other blueprints called for fire effects. The first blueprint, B_weapon fire. This blueprint calls the Niagara particles for the following. Shell ejects, muzzle flash, and the tracer. The second blueprint, B_weapon impacts, is used to show Niagara particle effects for the different impact areas like concrete or glass. The third blueprint, B_weapon decals, is for the weapon decal system at the impact point. GA weapon fire pistol has a gameplay effect GE damage pistol. This gameplay effect is used to cause damage to the hit target during gunshot. Go back to the GA weapon fire pistol. Apply gameplay effect to target node is used to apply the gameplay effect. Let's explore this gameplay effect. Search and open the gameplay effect GE damage pistol. Under the executions, calculation modifiers, modifier magnitude, the value set for scalable float magnitude section represents the damage caused by this gameplay effect. This value can be different for various damages like pistol fire, shotgun, or melee. This gameplay effect has a configured gameplay queue under the section Gameplay Queues. Gameplay queue.character.damage taken. Right click this and search for references. You will find the GCNL character damage taken as the tagged gameplay queue. Open it. This gameplay queue also has a blueprint implementation with a lot of features. The sound effects for damage given, damage taken, weak spots, and kill. Animation montages for hit react when hit in different areas of the body. Decals in the body when hit by a bullet. Niagara particle effects for impact sparks. Camera shake for damage taken. Thank you for watching this lecture. See you in the next one. In this lecture, we will explore the gameplay tags in Lyra. Gameplay tags are used throughout Lyra to identify different components like gameplay abilities, gameplay effects, gameplay cues, gameplay messages, HUD slots, UI layers, input, and so on. These tags are used to connect and communicate between the components. Let's see where the gameplay tags are configured in Lyra. Go to Edit Project Settings. Under Gameplay Tags, you can see the gameplay tags configured. We can use the reference viewer to understand how these gameplay tags are connected between the components and where they are used. Go to the ability grenade duration message. This is the gameplay tag used by grenade to communicate the cooldown duration with the cooldown widget. In the reference viewer, you can see the communication between the grenade ability and the cooldown widget. Thank you for watching this lecture. See you in the next one. In this lecture, we will explore the different types of gameplay effects used in Lyra. Lyra uses gameplay effect for damage, heal, and cooldown. GE damage grenade is used to configure the damage level during a grenade blast. GE damage pistol is used to configure the damage level to the character hit during a pistol fire. Same applies to GE damage rifle auto and GE damage shotgun for rifle or a shotgun damage. GE instant heal part is the gameplay effect which gives health and heals the damaged character. Gameplay effects are also used in cooldowns. Cooldowns are used in gameplay abilities when a specific ability needs to be delayed after each execution. A good example is the hero dash ability and the grenade ability. Both needs to be delayed after each execution. We will understand gameplay effect in the upcoming lecture on demonstrating the gameplay ability weapon fire pistol. We will go through the gameplay effects in detail in the deep dive section and the extending Lyra section. Thank you for watching this lecture. See you in the next one. In this lecture, we will understand how the abilities we explored so far are triggered during the gameplay. There are three ways the abilities can be triggered: on input triggered, on spawn, while input active. Hero jump, hero death, hero dash, emote, grenade, and ADS are some of the abilities which gets active when the input is triggered. For example, each keyboard or mouse button press activate the ability once. Weapon fire pistol, weapon fire rifle auto are some of the gameplay abilities activated when the input is active. For example, when the keyboard or mouse button is pressed, the ability repeats until the button is released. Auto respawn, quick bar slots, spawn effect are some of the abilities which gets activated immediately when the character is spawned. These abilities run throughout the lifetime of the character. Thank you for watching this lecture. See you in the next one. Now let us see the abilities of the weapons in Lyra. Lyra has three inbuilt guns: pistol, automatic rifle, and a shotgun. The important thing to note here is that the gun firing ability is part of the weapon and not the character. The character holds the gun and aims at the enemy target, but the firing and magazine reload features are part of the weapon's ability. GA weapon fire is the ability for the gun to shoot. This ability executes the gameplay cue for the firing gun muzzle flash VFX and the impact point VFX. It also gets the hit location of the bullet and applies the gameplay effect GE damage weapon. This gameplay effect applies the damage to the enemy who got shot. GA weapon fire has three variations: GA weapon fire pistol, GA weapon fire rifle auto, GA weapon fire shotgun. Each has its own set of firing animations and VFX effects. There are also three different variations of the gameplay effects: GE damage pistol, GE damage rifle auto, and GE damage shotgun, with different intensity of damage. Pistol and shotgun has the firing ability, while the rifle has the automatic firing ability. The firing weapons has a reload magazine ability. When the magazine is out of ammo, this ability reloads the gun with a new magazine if available in the inventory. Weapon auto reload ability adds an automatic magazine reload ability to the gun. Thank you for watching this lecture. See you in the next one. In this lecture, we will explore the different character gameplay abilities in Lyra. GA_hero jump. When this ability is activated, the character can jump during the locomotion. GA_hero_ dash gives the ability to quickly flash jump in the moving direction. The dash ability has a gameplay effect for cooldown. The cooldown gameplay effect restricts the player to continuously perform dashing. Instead, there will be a wait time between the dashes. This wait time is shown in a cooldown widget. GA_ADS. The ability ADS, or the aim down sights, provides the ability to aim the gun at the target, and this ability also slows down the walk speed of the character. GA_hero_death. This ability kills the character when the health becomes 0. A gameplay cue is triggered to display a VFX effect during death. GA_grenade gives the ability to throw a grenade at the enemy which blasts at the target. The ability has a gameplay effect for cooldown. The cooldown gameplay effect restricts the player to continuously throw the grenades. Instead, there will be a wait time between throwing the grenades. This wait time is shown in a cooldown widget. The grenade itself is a separate blueprint which applies a gameplay effect GE_damage_grenade, which causes heavy damage to all the nearby players where the grenade blast happens. GA_spawn effect. This ability gives a visual effect to the character during the spawn and respawn activity. GA_quick bar slots gives the ability to change the acquired weapons from the inventory slots. Lyra provides an inbuilt on-screen inventory with 3 slots. This can be extended and customized for your game. GA underscore emote. This is a fun ability where the character plays a dance animation to display emotions. GA underscore melee. This is a basic melee or closed combat activity provided inbuilt in Lyra. We will be using this to extend Lyra later in this course. This ability will be explained in detail at a later stage of this course. Thank you for watching this lecture. See you in the next one. Enhanced input system in Unreal Engine makes it very easy to support multiple input devices in different platforms. For example, you can use both a gamepad or a keyboard to control your character in the game. You can also design your game for mobile or virtual reality platforms. In this section, we will go through the features in the enhanced input system with examples using Lyra. Using enhanced input system, keyboard or gamepad mappings can be created for different gameplay actions like jump, crouch, shoot, etc. Enhanced input system has 3 main components: player mappable input config or PMI, input mapping context or IMC, input actions or IA. For each input device like keyboard or mouse, a separate PMI file needs to be created. One or more IMC files are created for each PMI. The input actions are created under the IMC. For each action in the game which needs device input, a separate input action is created. Let us see how the enhanced input is configured for the shooter game in Lyra. The enhanced input configurations can be added at the main content level and also additionally to all the game feature plugins you keep adding to your game project whenever you release an update to your game. Let us consider the Lyra shooter game and see how the enhanced input plugin is configured. In the main content of the project, there are 2 PMI files, one for the keyboard and the other for gamepad. The common input actions are configured using the input mapping context, like the player movement, jump, weapon fire, weapon reload, crouch, etc. In the shooter core game feature plugin, there are 2 other extended PMI files, one for the keyboard and the other for gamepad. The additional input actions are configured using the input mapping context, like the melee, ADS, throw grenade, quick slot actions. Let us take 3 examples, weapon fire, crouch and quick bar slot actions, and see how they are configured in the enhanced input system. Go to the folder Content Input Actions. You can find the input action weapon fire. Open it and view. There are no specific settings within the input actions for key or button mappings. Next, in the folder Input Mappings, open the IMC default gamepad. The input action weapon fire is configured here. Gamepad right trigger is configured for weapon fire. Same way, open the IMC default keyboard mouse mapping. Input action weapon fire is configured with left mouse button. Open the PMI file in the configs folder. The input mapping context is configured to the PMI file. Follow the same approach to check the keyboard and gamepad mappings for crouch. In the IMC default gamepad face button right is configured for the crouch action. In the IMC default keyboard and mouse, left control button is configured for the crouch action. Same way for the extended input actions configured in the Shooter Core Gameplay Feature plugin. Go to the plugins, Shooter Core Content, Input Actions. You can see input actions for quick slot 1, 2 and 3. There are also two other input actions, cycle backward and cycle forward. In keyboard, all 5 input actions can be configured. But in case of gamepad, due to limited button availability, only the cycle backward and forwards features can be configured. In the mappings folder, open the IMC Shooter keyboard file and you can see the configurations for quick slot 1, 2 and 3 assigned to keyboard buttons 1, 2 and 3. Along with the cycle backward and cycle forward assigned to mouse wheel up and down. Same way, the input mapping context for gamepad is configured for cycle backward and cycle forward. For the gamepad, D-pad left and right. The IMC file is configured in the PMI config file. This is how the enhanced input actions are configured. Any new actions needed for the game can be easily configured the same way. Thank you for watching this lecture. See you in the next one. Lyra gameplay framework comes with an inbuilt character module with a male skeletal mesh Manny and a female skeletal mesh Quinn. The character module is provided with an inbuilt locomotion system and multi-threaded animation support for the best performance. The locomotion system supports the following animations: walk, run, jump, and crouch. Advanced techniques like distance matching and stride warping are supported in Lyra, which gives a realistic feel for our character during the start and stop of a run. Animation transitions into jog state or while landing from a jump. Orientation warping is supported in Lyra, which is a very important technique used to provide a natural feel for the bending of the lower part of the body character during the 360-degree movement. Turn-in-place animations are used when the character wants to turn left or right and can rotate himself in a 360-degree angle without moving from his current place. There are two types of animations used during the gameplay. The locomotion animations, which includes walk, run, crouch, and jump. These are full body continuous animations. The other type of animation is the animation montage. In an animation montage, a short animation is played during an event on top of the locomotion animation. In most cases, it is an upper body montage animation blend with the locomotion animation. For example, the rifle shoot animation while running or a melee weapon animation while running. The animation montage is also used during other actions like character dash, character roll, where the whole body animation montage is applied. Lyra also uses animation layers for the locomotion animations. There are 3 ready-made animation layers available. The unarmed animation layer when the character is not equipped with the weapon. The pistol animation layer when the character is equipped with a pistol. The rifle animation layer when the character is equipped with a rifle. The rifle animation layer is mostly reused for the shotgun. All these animation layers have two copies, the masculine and feminine animations for Manny and Quinn. Throughout this course, we will see how free Epic Marketplace assets for animations and characters can be used in Lyra. We will also explore how we can add our own new animation layers in Lyra. Thank you for watching this lecture. See you in the next one. In the Lyra framework, the game levels are called experiences. In this lecture, we will walk through the elimination and the control point experiences in Lyra. This section is just an overview of what Lyra experience is all about. Go to the Lyra installation folder, open the Lyra project. The level map default editor overview is loaded by default. Run the project. This level loads all the configured experiences from the game feature plugins along with a simple pawn. The pawn can be moved using the WASD keys. Enter the pawn into the elimination experience. In the elimination mode, the player and his team needs to kill the enemies in the opponent team. In this time-bound battle, the team with maximum kill wins. Enter the pawn into the control points experience. In the control points mode, the player will try to secure the control points for a period of time to gain points. The players and bots are respawned during the time-bound battle. The win condition is based on the team which secures more points. In the upcoming videos, we will explore the Lyra framework components and build our own next-generation video game using Lyra. Thank you for watching this lecture. See you in the next one. In this lecture, we will install Lyra starter game from the Epic Marketplace. Open the Epic launcher, go to the Marketplace tab, search for Lyra starter game. I already have it downloaded. Once you download, you get the Create Project button enabled. Click the Create Project button. Browse a location for the Lyra course project. Select the version as 5.2. Click Create. The Lyra course project will be downloaded to the specified location. Go to the project folder, open the Lyra starter game, Unreal Engine project file. The default editor overview level will be opened. Run the level. You can move the pawn using WASD keys. Get into the front end. Click Play Lyra. Start a game. Select Expands. The Lyra game gets started. This is just an installation test. We will go over the details in the upcoming videos. Close the project. Let us now generate the Visual Studio C++ project files for Lyra. We won't work in the C++ part of Lyra, which is for an advanced level if you want to make changes to the core framework of Lyra. But we will have a lecture or two to make some minor changes to the C++ code to show you the power of Lyra and what you can achieve with it in upcoming lectures. Most of the course will be targeted to use Lyra as a framework and work mostly in the blueprint area. Right-click the Lyra starter game and choose Generate Visual Studio project files. This will generate the required C++ files and the Visual Studio C++ project solution. Please make sure the Unreal Lyra project is closed now. This is very important before you open the Visual Studio solution. You can open the Lyra starter game Visual Studio solution. This will open the C++ project in Visual Studio. In the Solution Explorer, right-click the Lyra starter game and select Build. You can monitor the build process in the output window. You can open the output window from the View menu output. If everything is going good with your installation, Lyra C++ compilation will be successful. Thank you for watching this lecture. See you in the next one. In this lecture, we will explore some advantages of using Lyra sample game as a reusable framework helpful in game development and to develop high-quality modern video games. Lyra follows a modern approach to game development using the game feature plugins and modular gameplay development. In Lyra, game features are developed as separate modules connected with each other. These features are installed as plugins. It brings in a lot of flexibility as a plug-and-play system, easy to add or remove features to your game without affecting the existing game. Lyra is built on top of the gameplay ability system with lots of helper features and examples pre-configured. Lyra comes pre-built with a fully functional shooter game framework which can be expanded. Biggest advantage of using Lyra as the base for your game is that it can be used as a low-code platform where you can speed up your game development process dramatically once you understand Lyra. Environment artists are highly benefited by using the inbuilt features in Lyra to demonstrate and test their environments almost instantly. Advanced game developers can build their features with ease and maintain it in the long run. Lyra made game development much easier by building subsystems and components for modular gameplay development. Let us look into some of these in this section as an overview. Lyra Quickbar component is an on-screen inventory component to maintain the equipped weapons. Lyra Inventory Manager component is used to add and remove the items from the inventory. Lyra UI extension subsystem makes it easy to load dynamic widgets into the UI head in respective slots. Lyra Gameplay Message subsystem is used for communication and sending data between the components or modules in Lyra. Lyra Experience is a modular gameplay design approach used to build a feature in a video game. Using this approach, a feature for a video game can be developed as a plug-and-play module which can be added and removed easily when a game is developed over a period of time. Lyra user-facing experience is the modular gameplay design to assemble the UI screens in a specific order before loading a Lyra experience, which includes the loading screens. Lyra team subsystem is used to separate the characters in the game to different teams and manage different team-related functionalities. Lyra equipment manager is used to equip weapons for the characters in the game. Lyra indicator manager component is used to show nameplates for the teammates in the game. Music manager component is used to handle the sound system and music for the game. Lyra uses animation layers for different character abilities, making it easier to manage animations as separate modules. Lyra supports multiplayer game development inbuilt using the gameplay ability system. Thank you for watching this lecture. See you in the next one. Gameplay Ability System or GAS is a framework developed as a plugin by Epic Games. GAS makes game development much more easier and it speeds up the development of RPG type of games with different abilities for the characters. And it also supports multiplayer features with ready-to-use and easily maintainable approach. Setting up the gameplay ability system manually needs significant work in C++. But the Lyra framework is already built on top of the gameplay ability system. This makes it even more easier with a lot more reusable features, making the gameplay development an enjoyable experience. Let us explore the features of GAS at a high level in this section. And throughout this course, as we explore Lyra, we will be dealing with different aspects of GAS. First and foremost thing in GAS is the gameplay abilities. The abilities are the capabilities which can be built around a character or a weapon held by the character or even the game itself. For example, the character can have the abilities like jump, dash, and throwing grenades. The weapon pistol held by the character can have the abilities like fire and reload. The game itself can have abilities like auto respawning the character after death. Next is the attribute. The attributes are mainly used to store values for different aspects of the character. The character health is a good example for attributes. The health value is used throughout the game for different features. For example, the health bar shown in the screen displays the health attribute value. When the health becomes 0, the character dies. Next, we will look into the gameplay effects. Effects are used for different purposes, which we will explore in a separate section. At a high level, the gameplay effects are used to change the attribute values. The damage effect reduces the health attribute. The heal effect adds to the health attribute. We also have gameplay cues. Cues are used mainly for visual and sound effects for specific events in the game. For example, detonating a grenade involves a blast sound, smoke, and a camera shake. Next, we have gameplay tags. They are the identity of the gameplay ability system. Every GAS feature is identified by a gameplay tag, which is a hierarchical name. For example, gameplay ability hero jump is identified as ability.type.action.jump. Similarly, the gameplay queue for weapon pistol fire is identified as gameplay queue.weapon.pistol.fire. Gameplay tags are used for abilities, events, message, HUD slots, input, cues, and effects. Finally, we have the gameplay messages and events. The gameplay messages are a way for the communication between different components or modules in the gameplay ability system. A good example is the respawn timer shown on screen when the character dies and then respawned. The respawn widget displayed on screen receives the gameplay message with the duration data from the gameplay ability auto respawn. Thank you for watching this lecture. See you in the next one.